Okay, so now we're working on your 4-3 vocab support to begin with. So make sure you put your class period. So 5 for me. What we're given is the figure at the right, and then we want to prove that these two triangles are congruent, and there's an example. So basically, what we have is similar. We've got this figure, and we want to prove these triangles congruent. The explain part is sort of like this one, but I'm going to abbreviate it because I don't want to write out, list the information, and so forth. So I'm going to shortcut it a little bit, and the explain is just going to be given, and then the justify is also given. So what we know are two sets of parallel sides are there. Now the next part says angle HJL, which is this angle, is congruent to KLJ, which is this one. So those being equal, and then the other ones also, these equal to these. So what I want you to put for this explain part is use an angle postulate or theorem. Use an angle postulate or theorem. Use an angle postulate or theorem related to parallel lines. Related to parallel lines. So in our case, JL is the transversal, so these would be alternate interior. So ours is going to be alternate interior angles theorem. Alternate interior angles theorem. Remember, that means they're on opposite sides of the transversal and they're between the parallel lines. Okay, the next part, they have JL congruent to LJ, which is reflexive. What we're doing for this is ASA. So for my explain part, what I want is I need this included side. Need an included side. That means a side between two angles. Side between two angles. So that'd be reflexive. Reflexive. So you see these have one mark, and then you have your side, and then these have two marks. So we've got the reflexive side that's between two angles. Any questions? Okay, so now for this part, if we know the triangles are congruent, this is where you choose from SSS, SAS, ASA, or AAS. Those are the four shortcuts that we know. Side, 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 angle, angle, or angle, angle, side. And in this case, we have ASA. Okay. So next, here's an example problem you can look through. And we're going to do 1 and 2, but we're not going to do 3. Okay, so for number 1, we're not going to really copy the figure. We're just going to mark it. Mark it with the congruence symbols you need to prove by ASA. So if we're using ASA, that means we're going to need the shared side and then this angle equal to this one. So that's going to be A. And this one equal to this one. So that indicates it's going to be ASA. So that's what you need for number 1. Just make your drawing look like that. The next one's talking about AAS. And so we know our vertical angles are equal. We know our 90-degree angles are equal. So the side we're interested in has got to be this short leg, because we need AAS. So AAS with AAS. Any questions? I'm not going to write it out, but another possible answer would be use the hypotenuses as the sides that are equal. So like in second period we did this one with angle, angle, side. So again, it's still 2 sets of angles that are consecutive and then a side across. So either this way, or you could say with the hypotenuses as the sides equal. Any questions? The main thing is it cannot be the side in between these 2 angles. Okay, number 4. What additional information would you need to prove each pair congruent by the stated theorem? So if we're using ASA, that's going to be the angle with the shared side and the angle here, ASA. So that's going to be angle ABD equal to angle CBD. So that makes it use ASA on the vertical line. For number 5, this is AAS. And so you can either, these have more than one possible answer, but I just want to keep it like this one for AAS, which corresponds to this. So we'll have angle JMK congruent to angle LKM. So that would make it AAS. The other way is to use the red part that's marked. So, or JKM congruent to angle LMK. So both of those are possible answers. You don't have to put both, but if you want to, you can. Any questions? Okay. This one, ASA, so we're using our vertical angles. Now, we can't use angle Y in this case, because that'd be AAS. We want angle side angle. So that's going to be angle X equal angle V. So that one just has one answer. The next one, AAS theorem, and so we can put our S here for the shared side, and if it's AAS, that's the same as SAA, so side angle angle. So it's going to be angle Y equal angle O. So that'd be angle side. The next one we have AAS. So if our side is right there, that it's got to be the angle P. Angle side. Angle P equal to angle A. So again, angle side. Number 9, ASA. So you've got your angle, you got your shared side, so then it's got to be this angle, which is CYL, and equal to this angle, ALY, alley. I guess I should have put the angle symbol in front, but that's okay. Alright, so there's the first 9. Any questions? Okay, so when I looked at number 10, this has a whole lot more blanks than you're used to. This has 9 of these and 4 of these, and I'm not going to make you do that many, so we'll just skip number 10. That was like a 9-step proof with many blanks, so we're skipping it. Okay, number 11. Write a paragraph proof for this. WX is parallel to ZY, and this one's parallel to that is given. So it is given that WX parallel to ZY and WZ is parallel to XY. So what that means is that this angle equals this one and this angle equals that one. So that means angle XWY equals angle ZYW and angle XYW equals angle ZWY from the alternate interior. From alternate interior. I'm just abbreviating it alt-int. Okay, that's your main part of the sentence. The next part has to do with the reflexive side, but I'm going to reread this. It is given the Wx is parallel to Zy and Wz is parallel to xy. So that means you have angle xwy equal to angle zyw and angle xyw equal to angle zwy from alternate interior. Okay, the next part is about wy congruent to yw. Wy is congruent to yw from reflexive. So then that means angle, side, angle. So we put the triangle congruent statement, wxy congruent to triangle yzw from ASA. So again, that last part, you couldn't say wy equal wy because this one has 2 marks and this has 1 and this has 1, this has 2. So you got to do your matching or corresponding letters. But yeah, that's reflexive for wy to yw, and then you got your triangle proof statement and ASA. All right, number 12. Given those are congruent, dB is congruent to BD by reflexive, and then on this one it's this side with those angles, so it's AAS. If they used angle 4 with angle 1, it'd be ASA, but this is AAS. Any questions? Okay, we're going to skip number 13 because there are 3 smaller triangles than overlapping ones and the big one. So I'm going to skip 13. Okay, now let's go to the reteaching part. The practice part. So this says name the 2 triangles that are congruent by ASA. So this one shows an angle, then a side, then an angle. So that's ASA. As well as this one, but this other one is AAS. So you want these, so triangle RQS congruent to R starts with 1 mark, and so it's TUV. TUV. Okay, on this next one, they still want ASA, bless you, which is what this is and this is. But this one's AAS. So it's going to be these 2 answers. So triangle ACB. And A had 1 mark, J has 1 mark, so JLK. Any questions about that? Okay, this one's showing angle, side angle, and so is this one, and this one is angle, side angle also. So really all three. So we have HGI, so the acute angle, the right, and then the other letter, how I named it. So then the acute angle on this one is Q, and then we need O, and then R, and then N is the acute angle, so NMP. NMP. Okay. So that one, all three triangles were congruent by ASA. Any questions? Okay, so then this one, we've got BD perpendicular to AC, so that's why there's a right angle. So what that means is you got your given statement. It's using definition of perpendicular, so that would be that this angle and this angle are right angles that are listed. So angle ADB and angle CDB are right angles from the definition of perpendicular. Then they have that they're congruent because all right angles are congruent. All right angles are congruent. Now they switch up the letters a little bit. So what they're talking about is ABD and CBD, this one. Why those would be equal is if you go back to what this word was up here, which is bisect. This bisects that. So this is definition of angle bisector. Definition of angle bisector. The next part is using the reflexive, which would just be BD congruent to BD. And then you can write your triangle statement here. Triangle ABD congruent to triangle CBD. And the reason is ASA. Any questions on that? Okay. Your next one, you have sides and angles that are given, and this angle is equal. KLJ and MLN. Those are from vertical angles are congruent. So at that point, you'd have angle, angle, side. But they want ASA. So because they want ASA, then we've got an extra statement about this angle equal to this one. So K congruent to angle M. And so now we have what they wanted, which was ASA. So then you put triangle JKL congruent to triangle NML from ASA. Okay, number 6. This one, we put our given statement. And then the reason these are equal, vertical angles. Vertical angles are congruent. And then this is an example of AAS. So you put your triangle statement here, PQT, congruent to triangle RQS from angle side. Any questions? I like that they're just so short. Okay, then number 7. This one has your given statement first that we have to write. BD is the angle bisector of ABC and ADC. So that's given. So you basically are writing what's typed up there. BD is the angle bisector of angle ABC and ADC. And then because of that, if BD is the bisector, then we know angle ABD equals angle CBD. ABD equal CBD, this one. And we also know, oh, the D is not marked. The D is the one in the middle. Put the D in the middle. So then you have ADB is congruent to CDB also. Okay, so that's from angle bisector. So then with the angle BAD, that's the third angle in the triangle. So this would be the third angles theorem. Third angles theorem. That angle is equal to that one. Then we also have the BD, which is the reflexive side. And that's going to give us enough for this A, and this S. So we put our triangle ABD congruent to triangle CBD. And we'll end up skipping 8 and 9. Okay. Okay, so now we're done with that part, and so now you could work on your Math Excel.